Welcome back, everybody. This is going to be the last video of this chapter, and I know I talked about this slides here from my previous video number 3, but I don't think it's clear enough, so let's go over that one more time. So the oblate surface is not being perpendicular to any one of the 3 principal projection plane. As you can see, this is the one that is your oblate surface. This is qualified to your oblate surface as this is not perpendicular to any of these 3 viewed 3 principal projection plane. So when you start with this oblate surface, now that you have the B1, you're gonna have B1 to B2 here, and you're gonna create one reference line, the top and the front view, and then you're gonna project perpendicular to the top, and this A is gonna be this A here, and your B1 here, you project them up, it's gonna give you B1, B2, project this up to B2, B1 project that to B1, and now with that true length B1 and B2, now you're gonna make another projection line that is parallel to this B1, B2, and create one reference line called the top view and the auxiliary view 1. The auxiliary view 1, from here, your A, project them perpendicular to this reference line and create this this A here. Always this distance x here equal to distance here. You get 1 point, and then same thing, this distance here to get B1 and B2 is basically you're gonna B2 project this B2, so your distance from here to here is equal to the distance here to here. This point B1, B2 is the same point because this is parallel, this is all the same line that you project from this B1, B2, and B2 at this point is the same distance, the distance here, and the distance here is the same distance. Therefore, this distance Z is going to create 1 point here. So now the oblate surface turns into one of the appear as an edge. This is going to be edge. So once you create this edge, now you're going to create auxiliary view number 2 to get the true size and the true shape of the oblate surface. So you would project them down, and then you have this reference line here. This is auxiliary view 1, auxiliary view 2. This is the one that we want to accomplish because you want to see the true size of the oblate surface. Now that you do the same thing, project this down, and then you have point A, and it's the same distance here, point A. You always skip a point to get the distance. So the distance here, Y, skip this view, equal to the distance Y. This distance Y again, same thing, equal to the distance Y. So your A, B2 is over here. Now it's created the true length of AB2. Same thing, B2, B1 is the same point here, B1, B2, but it's different distance because you got Y here, and you got, let's say, Z from B1 to this reference intersection point. So this distance here is equal to this distance here to create that B1. Now that you can generate this true size of the oblate surface. So for this view here, and again, if you need more detail, when this detail is not enough to show information, you're gonna have to enlarge it to 2:1 enlargement of the auxiliary view. VV is shown here. So you enlarge it to 2:1 to add more detail to it. And now let's conclude this chapter 8 by going through the summary. And as you can see, an auxiliary view is a view with its lines of sight perpendicular to an inclined surface of an object. An auxiliary view serves three purposes. It illustrates the true size of a surface. It illustrates the true size of a surface, and it can project and complete other views. A secondary auxiliary view is one that is projected from a primary auxiliary view to more fully illustrate an object. The secondary auxiliary view is needed only if the primary auxiliary view cannot provide you with more information. Then you will need to create the secondary auxiliary view. A partial auxiliary view is used to save drafting time and cost by eliminating one or more regular view. And some of the partial view and something that you don't want to see, you just want to see the most important part of the detail, then you don't have to completely show the auxiliary view. An auxiliary section is an auxiliary view in section. In other words, you're cutting section to see what is the section looks like. It is drawn in the same way as the remove section. When you remove section back in chapter 7, and it's the same way that you cut it off and show what is the sections looks like. A half auxiliary view can be used when the auxiliary view is symmetrical. Only when it's symmetrical, then yes, you would do the half. You don't have to show the other half, just show half of the view. That would be sufficient. And some of this homework here is good homework, and I would like you guys to do one of each. You don't have to finish all this 4. I will go over this 4 problem sometime in our online class or Thursday. So this is your homework assignment. Problem 8-5 is a good homework assignment. And then problem 8-7 is also a good homework assignment. If you can finish these 2 homework assignments and submit them online, that would be good, and you get the full credit for this online class. But the rest of it, I'm going to show you, you don't have to do this 8-6. You don't have to do it. And again, the homework is this one here and that one here. So problem 8.5 and 8.6. You don't have to do that. That's I'm gonna have to show you when I see you guys Thursday or online class. So, and then 2 other good homework, and this is not the homework. Again, you don't have to do homework. This is a lot of work to do, and I would show you in the class this coming Thursday. And one more homework is 8-30, 8-31 is also a good practice, but you don't have to do it. I'll show you guys when I see you either Thursday or online Tuesday. With that, that's finish my chapter 8. And next week, once we finish next week, we have one more Tuesday the following week, and then we have a Thanksgiving holiday, and then after 2 more weeks, and then you're gonna finish up your exam 2, and then we should be done with this next chapter in right after Thanksgiving.